Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the EA-6B Prowler and EA-18G Growler, the carrier-based electronic warfare aircraft that shielded strike packages from Vietnam into the 21st century. If you enjoy learning how technology, tactics, and human decisions come together in combat, you can find more articles, podcasts, and resources at trackpads.com. On a carrier deck in the northern Persian Gulf in the winter of 1991, red and white lights wash over an aircraft inching toward the catapult. The EA-6B Prowler's 4 canopies glow with the green of cathode ray tube displays, tiny islands of light inside an otherwise darkened jet. The air wing is spinning up for another night into Iraq's dense belt of radar-guided defenses, and everyone on the carrier knows how dangerous that airspace can be. The strike leader on the bridge wants one thing above all for the attack aircraft headed inland: a clean jamming umbrella from the Prowler. Arsenal is the Friday feature of Dispatch, U.S. Military History magazine. Inside the cramped cockpit, the pilot keeps one eye on the catapult officer and the other on engine instruments that must stay perfectly in limits. To his side and behind him sit 3 electronic countermeasures officers, hunched over their scopes and displays. They turn a wall of anonymous symbols and frequencies into a mental map of Iraqi search radars, tracking radars, and missile guidance beams that could kill their friends. On the wings hang jamming pods and high-speed anti-radiation missiles, silent threats to any radar crew that lingers too long on a strong track. It is a small crew facing a very large network. The catapult stroke slams the Prowler into the night, pressing the crew back in their seats for a few short, violent seconds. The aircraft claws into the darkness and then settles into a climb ahead of the main strike package, slightly offset so its invisible energy can pour over the same airspace the attack jets must cross. Down below, Iraqi radar operators suddenly see their scopes fill with noise or blank out at critical moments. Surface-to-air missile crews try to switch modes, change frequency bands, or hand off tracks to neighboring sites, only to find that every move is answered by a shift in the jamming pattern. The duel is invisible but deadly serious. Hours later, back on deck, the Prowler crew hears the verdict that matters most. The strike aircraft are back, and the losses everyone once feared never came. They know the pilots in the attack jets will get the headlines for targets destroyed, but without the jamming umbrella, the night might have ended very differently. Decades later, when the EA-18G Growler takes over this mission with digital systems and a fighter's performance, the basic story will remain the same. These are the aircraft that fight the enemy's nervous system, so everyone else can fight the enemy's guns. The need for that kind of aircraft grew out of a specific problem. Early Cold War carrier air wings were built around aircraft that could drop iron bombs or employ early guided weapons, but they had very limited answers for new radar-guided air defenses. The Korean War and the opening years of the Vietnam War showed how lethal radar-directed guns and missiles could be when aircraft had to fly predictable routes and altitudes. Small electric versions of existing aircraft, loaded with crude jammers, tried to keep up by bolting new boxes into old airframes. They helped a little, but they were always a step behind as new radars appeared and integrated air defense systems spread across the map. The threat was growing faster than the tools to counter it. For the United States Navy and Marine Corps, the problem was particularly stark. Their attack aircraft had to fly from carriers at sea to fixed targets ashore, such as bridges, power plants, and airfields, often against enemies with dozens of overlapping radars watching every likely approach. Traditional fighter escort could not stop a radar beam or confuse a missile guidance signal. Stealth technology was decades in the future, and, even when it arrived, could only ever cover a fraction of the force. The services needed something different, a dedicated electronic warfare aircraft that could fly with the strike group, listen to the enemy's emissions in real time, and blind or deceive the radars that mattered most. Without that, every major strike would be a gamble. That requirement produced a lineage rather than a single design. The first serious step was the EA-6A, an A-6 intruder attack aircraft adapted to carry more sophisticated jamming gear into the skies over Vietnam. It proved that escort jamming could save lives, but its limitations underscored the scale of the challenge. The enemy's radar network was not a single sensor, but a layered system that included early warning radars, acquisition radars, tracking and missile guidance radars, and the command and control links that tied them together. Defending a carrier air wing meant dealing with each of those layers, often under fire and in bad weather. Crews needed more space, more power, and more specialists to make that work. The EA-6B Prowler, with its 4-person crew and airframe optimized for long, low-level carrier missions, was designed to tackle that complexity directly. As Soviet-style air defense systems proliferated and then spread to regional powers, it became the joint forces' primary tool for suppressing and confusing enemy radars across wide areas. By the end of the 1990s, after the retirement of the Air Force's dedicated EF-111 jammer, the Prowler was carrying almost the entire burden of airborne radar jamming for the United States in combat. Its presence could change the risk calculation for every aircraft in a strike plan. That was both a measure of its success and a warning sign. That success created a new problem as the years passed. The Prowler's airframes were aging, and the threat environment was becoming fully digital, agile, and networked, with radars and command systems that could shift modes in fractions of a second. The Navy could not simply retire its only dedicated jammer and hope that stealth aircraft and standoff weapons would be enough for every future war. Planners still needed an aircraft that could stay with the main body of the force, see what the enemy sensors were doing, and respond in real time. The answer would be another carrier-based electronic warfare aircraft, this time built on a modern fighter airframe with room to grow. That answer was the EA-18G Growler, the latest link in a lineage born from the need to punch holes in the enemy's electronic shield. So far, we have seen why the Prowler and Growler were needed. Now we can follow how they moved from early sketches to frontline squadrons and what it felt like to live and work inside them. The development story starts not with a blank sheet of paper, but with an attack bomber that was already taking shape for the fleet. That alone shaped almost everything that followed. The EA-6B Prowler story began on drawing boards already busy with the A-6 Intruder all-weather attack aircraft in the early 1960s. As engineers refined the Intruder, they also explored an electronic countermeasures version that could escort strike packages through radar defenses rather than simply drop bombs. That first step produced the EA-6A, often nicknamed the Electric Intruder, a 2-seat conversion that went to war over Vietnam as a stopgap. It proved the basic concept of escort jamming and showed that a dedicated platform could reduce losses for an entire strike group. It also made the problem painfully clear, since the enemy radar network was layered and numerous, and crews needed more power, more antennas, and more specialists to keep pace. By 1966, the Navy committed to a purpose-built aircraft and funded Grumman to create the EA-6B. Engineers stretched the Intruder's forward fuselage to carve out space for 4 crew positions instead of 2. They reshaped the vertical fin with a large fairing that could house more antennas and supporting systems. They also integrated a completely new electronic warfare suite rather than simply bolting extra boxes into spare corners of the airframe. The prototype flew in 1968, and Prowlers joined fleet squadrons in 1971, just in time to support late Vietnam operations and then stand watch on carriers through the rest of the Cold War. Designers had to balance several competing demands as they turned ideas into hardware. They kept the intruder's tough, low-level carrier airframe and its twin J-52 engines, which offered range, payload, and reliable all-weather handling over the sea. They accepted extra weight and drag from external jamming pods and numerous antennas because there was no other way to project enough power across multiple radar bands. They also decided that 3 dedicated electronic countermeasures officers sitting with the pilot were worth the complexity and cost. In a world of analog receivers and early digital processors, human judgment about which signals to attack and when to change tactics remained central to survival, so the crew size was a design choice, not an accident. At a glance, the EA-6B Prowler was a United States carrier-based electronic attack aircraft flown mainly by Navy and Marine squadrons from the early 1970s into the 21st century. It carried a crew of 4, a typical load of jamming pods and high-speed anti-radiation missiles, and flew subsonic dash speeds a little over 500 knots with a combat radius measured in hundreds of nautical miles. Its successor, the EA-18G Growler, is a United States Navy electronic warfare variant of the 2-seat F/A-18F Super Hornet. The Growler has a pilot and an electronic warfare officer, fighter-like performance including supersonic speed, and the ability to carry both jamming pods and air-to-air or air-to-ground weapons on 9 external stations. Together, they form a clear lineage. Over its production run from the late 1960s into the early 1990s, roughly 170 Prowlers were built and steadily upgraded. Expanded and improved capability packages modernized their receivers, processors, and jamming techniques so crews could keep pace with newer radar systems. Those efforts kept the design relevant from Vietnam through operations in Grenada and Libya into the Persian Gulf and on into the long wars after 2001. By the end of the 1990s, though, airframes were aging and the analog architecture was straining in the face of digital, agile enemy radars that could shift modes very quickly. When the Air Force retired its own dedicated jammer, the EF-111, even more demand fell on the Navy's Prowler community. The Growler's path from concept to production reflected all of those pressures and lessons. The Navy chose to base its new electronic attack aircraft on the F/A-18F to exploit common airframes, engines, and logistics across the fleet. Boeing and Northrop Grumman reshaped the Super Hornet with new fairings and fences, wingtip electronic support pods, and a densely packed equipment bay where a gun once sat. The first prototype flew in 2006, and the EA-18G entered operational service in 2009, sliding into fleet squadrons as Prowler units gradually stood down. The result was a jammer that could launch, refuel, and maneuver alongside modern strike fighters rather than orbiting at a distance, which helped close the loop between kinetic and electronic attack. Seen up close on a carrier deck, a Prowler looked like an intruder that had grown a second brain. The fuselage was longer and topped by a tall fin with a cigar-shaped fairing full of antennas. The in-flight refueling probe stuck out from the nose with a noticeable offset that improved pilot visibility, something crews appreciated on dark nights at the tanker. The canopy had a faint gold tint to shield the crew from their own emissions and to help control reflections. Under the wings hung squat pods housing the ALQ-99 tactical jamming system, each with its own generator and tunable transmitters, ready to soak selected radar bands with tailored noise or deceptive signals, while twin J-52 engines pushed the aircraft down the catapults and into dense night air for long, heavy sorties. Inside, the Prowler was all business and very little spare space. The pilot sat in front on the left, focused on flying a heavy, draggy aircraft exactly where the mission demanded, often in turbulence, weather, or near the edge of weapons envelopes. To the right sat the senior electronic countermeasures officer, responsible for navigation, communications, and coordinating the electronic fight with the rest of the force. Two more electronic countermeasures officers in the rear seats stared into scopes and digital displays, sorting through a forest of radar pulses. They identified which emitters were priority threats and matched jamming techniques to each one, while intercom calls, checklists, and quick threat updates bounced between the 4 crew members and strike leaders on other radios, waited for the simple confirmation that mattered most, that the jammers were on and effective. Their primary tool was the ALQ-99 system, fed by wideband receivers and controlled from the consoles. In training, crews practiced methodical workflows, classifying emitters, assigning pods, and managing heat and power limits so equipment stayed within safe margins. In combat, those same workflows became more improvisational as radar operators on the ground tried new modes, shifted frequencies, or used silent gaps to lure aircraft into engagement zones. The Prowler crew could respond by switching from barrage jamming that blanketed an entire band to more precise techniques that targeted specific radars as they appeared. They could also cue high-speed anti-radiation missiles to punish any site that persisted, and on many sorties, they provided communications jamming and gathered signals intelligence, recording patterns and parameters that analysts ashore would study for future campaigns. Walk around a Growler, and the family resemblance to the Super Hornet is obvious, but the specialization is just as clear. The wingtip missile rails are replaced by sleek pods that house ALQ-218 receivers, which constantly listen across a wide spectrum and feed a digital picture of the electronic environment to the cockpit. Under the wings, legacy ALQ-99 pods still appear, soon to be joined and then replaced by next-generation jammer pods that promise more power, agility, and precision. The nose contains an AESA radar that can support both navigation and targeting, scanning rapidly without moving parts. Fairings along the fuselage hide communication countermeasures and data links that connect the Growler to joint command networks and other shooters in the theater. The Growler's crew is smaller, but sits atop far more automation. The pilot flies a high-performance strike fighter that can keep pace with other Hornets from the catapult to the tanker and into contested airspace without struggling for position. The electronic warfare officer in the rear seat manages a fused display that overlays radar threats, communication nodes, and friendly tracks, selecting jamming assignments and weapons with hands-on throttle and stick controls and multifunction displays instead of rows of analog knobs. Modern software can recommend jamming plans, highlight likely emitters, and help deconflict multiple Growlers and shooters that are sharing the same sky. The human still decides when to hold fire to preserve surprise, when to concentrate power on a single threat that must be shut down, and when to spread effects across a wider area for a larger campaign. For the people who maintain these aircraft, life is dominated by pods, cables, and built-in test routines rather than by sleek lines. Prowler maintainers dealt with heavy, generator-driven ALQ-99 pods that had to be carefully aligned, tuned, and checked, sometimes in harsh weather on open flight decks or improvised expeditionary strips. Growler crews still handle external pods and connections, but much of the diagnostic work has moved into digital tools that can simulate threats and verify responses before the aircraft ever leaves the chocks. What has not changed is the feeling that these jets are the air wing's nervous system, the link between what the enemy's sensors see and what their weapons can do. When the jammers are down or short of parts, everyone in the strike group feels more exposed, and when they are healthy and loaded, crews across the carrier know they will not be going into harm's way alone. The story of these aircraft in combat really begins in the closing chapters of the Vietnam War. A handful of newly formed Prowler squadrons sailed west with carrier air wings that had already spent years fighting over North Vietnam. Their early missions were not glamorous because crews often orbited just outside the heaviest flak and missile zones rather than over the targets themselves. From those positions, they poured out jamming energy so that strike aircraft could slip through radar fans aimed at bridges, airfields, and supply depots. Those first deployments proved that a dedicated electronic attack aircraft could change loss calculations for an entire air wing, even when the jet itself never dropped a single bomb. Over the next 2 decades, the Prowler became a familiar shape in almost every crisis that sent American carriers toward contested shores. In Grenada, over Libya, and during clashes with Iranian forces late in the Cold War, its crews learned to deal with dense but sometimes brittle radar networks that mixed Soviet-style equipment with local improvisations. Each operation added fresh threat libraries and tactics to squadron playbooks, building a memory of how particular radars sounded and behaved under pressure. Over time, crews came to feel that the aircraft's real weapon was not only its jamming pods, but the pattern recognition skills of the people at the consoles. That quiet expertise turned raw electronic noise into practical protection. Desert Storm in 1991 was the moment when the Prowler's reputation became fully joint across the services. Dozens of aircraft from Navy and Marine units, divided between carriers and land bases, were tasked against Iraq's integrated air defense system that stretched from border radars to hardened strategic sites. Over thousands of hours on station, they fired well over 100 high-speed anti-radiation missiles and smothered key radar and communications nodes at critical points in the campaign. Those efforts helped the wider air operation achieve surprisingly low loss rates against a modern surface-to-air missile threat that had worried planners for years. When the Air Force retired its own dedicated jammer later in the decade, commanders reached for more expeditionary Prowler squadrons rather than walking away from the capability. After the Cold War, the aircraft did not fade into the background. In the Balkans, over Afghanistan, and during the long campaigns in Iraq, Prowler crews shifted from fighting dense, state-run air defense networks to suppressing a mixture of legacy radars, pop-up systems, and even radio triggers that insurgents used to detonate roadside bombs. The same wideband receivers and jamming techniques that once shielded tightly packed strike packages now helped protect patrols and convoys on the ground by frustrating remote initiators. That flexibility kept the airframes on deployment cycles that pushed maintenance teams and air crews hard right up to their final years in service. It was demanding work, but it showed how broad the idea of electronic attack had become. The Growler entered the story at the point where the Prowler could still do the job, but was running out of future. First deployed in the early years of the last decade, it cut its operational teeth supporting operations over Iraq and then enforcing a no-fly zone over Libya. There, Growler crews combined jamming and missile shots to hold down modern air defenses along a crowded coastline and protect a mixed coalition of aircraft. Since then, Growlers have appeared wherever carrier or expeditionary air power has faced sophisticated radars, from parts of the wider Middle East to patrols over the Red Sea and tense skies near Allied airspace. In each case, their mission has echoed that of their predecessors, to make sure the enemy's sensors see the wrong picture or none at all when the rest of the force moves in. Ask air crews what they valued in the Prowler, and many begin with its persistence. The intruder-based airframe gave it long legs and a generous payload, so a single jet could cover a strike package from the coast to inland targets and then stay overhead as the force exited. Jamming pods that once felt enormous beside early fighters provided enough power and frequency coverage to attack multiple radar bands at once. The 4-person crew could divide tasks and cross-check decisions under pressure, which mattered in an era when much of the threat recognition and technique selection depended on human judgment rather than automation. Commanders appreciated having a platform that could not only blind radars, but also fire anti-radiation missiles at sources that refused to shut down. Those same traits carried real costs. Extra weight and drag from pods, antennas, and fuel turned the Prowler into a slow, ungainly presence in a formation of faster jets. Pilots had to work hard to manage energy and stay in position when strike plans changed or weather forced rerouting. The aircraft's analog roots meant that every new capability tended to arrive as another box, cable run, or pod, which increased maintenance demands and sometimes produced awkward cockpit ergonomics for the crew. Late in its life, the type became notoriously maintenance-intensive, with aging wiring and structures that needed constant attention from skilled technicians. Crews also lived with the knowledge that a large, non-stealthy aircraft that constantly announced itself with jamming energy would always sit high on an enemy's target list. Growler crews trade some of those weaknesses for different ones shaped by their newer design. The aircraft can climb, accelerate, and maneuver with the strike fighters it escorts, and its sensors and processors can automatically assemble a wide-area picture from scattered emissions in a way the Prowler never could. Integration with modern data links lets it share threat tracks and jamming plans across a joint force rather than working in relative isolation. At the same time, the two-seat cockpit concentrates a great deal of responsibility in the hands of a single electronic warfare officer, whose workload in a dense fight can be intense during long missions. The aircraft still relies heavily on external pods, and while new generation systems promise more efficient power and agility, they also raise the technical bar for maintenance and mission planning. Neither design is cheap, and both depend on highly trained specialists to turn complex hardware into real protection. Over nearly half a century of service, the Prowler changed enough inside that crews often spoke of versions as if they were almost distinct aircraft. Early configurations gave way to improved capability packages that modernized the electronics suite with better receivers, quicker processing, and more flexible operator displays. Later upgrades added improved connectivity, the ability to employ newer models of anti-radiation missile, and refinements to self-protection and navigation systems that made long, dark flights slightly less punishing. In each case, the goal stayed the same: to keep the aircraft's jamming techniques effective against a steadily modernizing set of radars and communications. At the same time, operators wanted to squeeze more insight out of the signals it collected for analysts and planners on the ground. Structural changes to the Prowler were more modest but still important for a fleet that was aging in place. Strengthened wings and fuselages, new wiring harnesses, and updated avionics bays all fought the simple fact that the airframes were being asked to serve far longer than anyone expected when the first examples rolled out in the early 1970s. The creation of expeditionary land-based Prowler squadrons in the late 1990s and early 2000s, supporting joint operations far from carriers, was itself an evolutionary step in how the aircraft was used. It shifted the jet from a fleet-specific escort into a theater-wide enabler that might be based on a desert airfield one deployment and a carrier deck the next. That flexibility gave planners more options whenever a crisis loomed. The Growler began its life with the assumption that evolution would be continuous rather than occasional. From the outset, the aircraft carried digital receivers at the wingtips, an advanced phased array radar in the nose, and provisions for multiple external jamming pods under the wings. Designers and operators expected that the most important changes would come in software, pod internals, and threat libraries rather than in airframe shape or engines. That expectation is visible in the Next Generation Jammer program, which is replacing the long-serving ALQ-99 pods with new systems tailored to different frequency bands. The first of these mid-band pods has already reached initial operating capability and is planned to be followed by low and high-band companions, giving Growler crews a modular toolkit they can adjust to specific theaters and problems. Taken together, the Prowler and Growler have shaped how American naval and joint forces think about the relationship between the electromagnetic spectrum and physical combat power. For long stretches between the early 1970s and the late 2010 era, Prowlers were the only dedicated airborne radar jammers available to the entire United States military. That meant planners often built campaign timelines around when these aircraft could be in theater and on station. Their presence in almost every major operation of that era taught commanders that suppressing and deceiving enemy sensors was not a niche supporting task. It was a central requirement for surviving and winning in defended airspace. The Growler has extended that legacy into an era of agile digital radars, networked command systems, and long-range precision weapons. Its ability to escort strike fighters directly, jam and attack threats, and share information across a joint force makes it one of the quiet anchors of modern power projection from the sea. As new pods and software arrive, the basic concept first proven by Prowlers over Vietnam and refined over Iraq and other campaigns continues to evolve on new hardware. These aircraft still fight the enemy's ability to sense, decide, and communicate rather than destroying physical targets alone. In doing so, they carry forward a way of thinking about warfare that treats control of the spectrum as vital terrain. For listeners who want to see this lineage in person, the United States offers a rich scattering of museum aircraft and gate guards. Prowlers sit under cover at the National Naval Aviation Museum in Pensacola, on the ramp at Whidbey Island where many of them once operated, and in major aviation museums from Seattle and California to Oklahoma and Virginia. At places like the Udvar Hazy Center, visitors can walk underneath an aircraft that once orbited silently above crowded strike packages and think about the invisible work that kept so many other crews alive. Growlers, still very much frontline machines, appear more often at air shows and in carefully managed public displays than in museums today. In time, they too will take their place as static reminders of a long-running electronic war. You can also hear narrated versions of Arsenal features as part of the Trackpad's podcast feeds and Dispatch audio editions, which connect these machines with the people who flew, maintained, and faced them in combat. That is the final legacy of the Prowler and Growler story, a reminder that behind every piece of hardware are crews and opponents whose lives turned on how well these aircraft performed their quiet, invisible work.